Hello friends, welcome back to our channel. So today we'll see one more concept in design and analysis of algorithms, that is different types of time complexities. Types of time complexity. So in our previous session we have discussed about the introduction to analysis of algorithms. So in that we have seen the two parameters, that is a time complexity and the space complexity are the two parameters to evaluate the performance of an algorithm. So time complexity means how much time it takes to execute the algorithm or a problem or a task. So there are different types of time complexities. Now we'll see one by one, right? So first I list out the types of time complexities and then we'll go one by one. First one is a constant time complexity. Usually it is denoted as order of 1. Next, linear time complexity. It is denoted as order of n. So we will see this order. What is the order, right? So there will be different asymptotic notations. So that we will discuss in our further session. Just you can observe the denotations, just like a denotation. Order of n and order of n. Okay. Next, logarithmic time complexity, which is denoted as order of log n. Usually the base will be 2. Next, order of n log n. So there is no specific, so we can call it as a n log n time complexity. Time complexity. So in the name itself indicates, so then it will be denoted as order of n log n. So which will be similar with the logarithmic time complexity. And the next one is quadratic time complexity. Quadratic time complexity, so which will be denoted as order of n square. Order of n square. So these are the 5 different types of time complexities. So not every algorithm will have a single time complexity. Okay, so based upon the algorithm and based upon the inputs we are giving, the time complexity will be changed. So obviously the time complexity depends upon the input size. So the problem with a different input size will give a different time complexities. Right. So let us see one by one. First, coming with the constant time complexity. Constant time complexity. So just now we have said that time complexity means the time taken to execute the problem or to perform a particular task. So here, number of steps required to execute the problem is a constant. That means if the input size is increased, even though the number of steps required to execute the problem remains constant. So irrespective of the input size, the number of steps is constant. So the time doesn't affect with respect to the size of the input. So time doesn't affect or does not vary if the increase in input size. So if the input size is increased, then also the time taken to execute the problem will be remains same. Okay, so best example for this one is all the arithmetic operations. all arithmetic operations. So even though the number of the input increases, the performance of this operation will be same. The addition or subtraction or multiplication or division. The time doesn't changes. So such type of statements, we can say the time complexity will be order of 1 or 2 or 3 or 4. It's a constant. We simply say it as a constant. Right? So next, coming to the second category, linear times complexity. Linear time complexity. So which is usually denoted as order of n. So here the number of steps required to execute the problem depends upon the number of size, the input size. So if the input size is increased, automatically the time taken to execute the problem will also be increased. So number of steps required to complete or to execute the problem depends on input size. That means if input size increases, then time taking to execute will also increase. So that means directly proportional. Okay, so directly proportional. So the time is directly proportional to the input size. So if the input size is small, automatically the time taken to execute the problem will be low. And if the input size is more, the time taken to execute the problem will be more. That means a direct proportional. So best example for this one is linear search. So I think most of you are aware about these searching and sorting algorithms, because so if you are watching this design and analysis of algorithms, obviously you might be having a knowledge on searching and sorting techniques, right? So linear search means irrespective of the order of the elements, the search will be keeps on going from one element. That means every element will be compared. Okay, every element will be compared. For example, if you want to search some 100, okay, in 10 elements. Okay, if you want to search one element in 10 elements, if the element is at the last position, what we have to do? So every element we are going to search until it gives the success. So it takes some 10 steps to complete its execution. For example, if we are having 100 elements, it will take 100 steps to complete its execution if the search element is at the last position. Okay, so similarly, linear search is the best example for this linear time complexity. That means if the size increases, the time will also be increased. So, and obviously one more example, general example, if you are having a lock and you forgot the key and you are having a bunch of keys, what you will do to open the door? So you will try with each and every key. So if the correct key is the last key in the bunch, obviously you have to compare, you have to try for all the keys in the bunch. If the size of the keys, bunch of the keys increase, automatically the time taken to open the door will be also be increased. So such type of complexity, we call it as a linear type complexity. Hope you understood. Then coming to the third one, logarithmic time complexity. Logarithmic time complexity, and it is denoted as order of log n. And here the number of steps required to execute the problem will be reduced for every iteration. So the problem space will be reduced. So initially, if the problem space is n, after completion of the first iteration, the problem space will be reduced to n by 2. And obviously, again, the same problem will be divided into half, that means n by 4. So this process will be repeated until the problem has been solved. So such type of things we call it as a logarithmic time complexity. Okay, here the problem will be divided into small bits or small parts, and after every division the problem space will be reduced to half. Right, see here problem will be divided into small parts. So after each division, the space, the number of steps, or you can say number of steps, will be reduced to half. Okay, so such type of algorithms, the time complexity, we call it as a logarithmic time complexity, and it will be denoted as order of log n. Okay, now the best example for this one is a binary search. Binary search. So most of you know about this binary search. Again, I will say that one. So the first constraint is, if we want to implement this binary search, the elements should be in a sorted order. All the elements should be in a sorted order. If the elements are in sorted order, if you are searching for a particular element, so first it will find out the middle element, and it will compare the search element with the middle element, and if it is less than, so then the search position will be shifted towards the left part, and if it is greater than, the search position will be shifted towards the right part. For example, so 10, 20, 30, 40, 50. So if search element is some 10. So first it will find out the mid. In the first iteration it will find out the mid. So 10 is less than 30. So next search space will be this one. Next search space will be this one. So that means after every division, the complete steps are reduced to half. And in next iteration, again here we have to find out the mid and have to repeat the same process. So the same process will be repeated. That means the division of sub-problems will be done until it reaches or it completes its execution. So binary search will be the best example for this logarithmic time complexity. Okay, reducing the search space or reducing the steps to execute the problem. Coming to the next one, that's also similar to this logarithmic, which is order of n log n. So the same thing happens here also. So we are saying that order of n log n, you can see here also the problem will be divided into small parts. Small parts. Again, same. Each part, okay, after each division, number of steps required to solve the problem will be reduced to half. So this is nothing but our logarithmic time complexity. After that, collaborating all such small parts. So collaborating all small parts to complete the execution, right? For example, one problem is divided into n parts. Okay, one problem is divided into n parts. Sorry, 1, 2, 3 and so on. Okay, now you can see for each part again it is divided. Okay, so for this we will say it as a log n. Again here it is a log n, here it is a log n. So like this, if we are having some n problems, so then we can say it as a n log n. That means after dividing the parts, after completion of this one, again we have to collaborate all the parts to complete its execution, right? So the example for this one is merge sort. So merge sort. So in this merge sort, what we are doing? So we are dividing the complete elements into two halves. Again, from the right half and from the left half, again we are dividing it in two halves. Again we are dividing the left half and right half into two halves. Later we are applying the merging operation, and again we are starting collaborating the left and right halves to combine the complete sorted order, right? So that is the best example for the merge sort. Okay, and this type of algorithm is more efficient if the size of input is large. So this algorithm is efficient and works good for large inputs. For large inputs, that means if the input size is more, this is more suitable. Okay, this type of algorithm will be suitable, and the time complexity we call it as an order of n log n. And the last one, quadratic time complexity. Quadratic time complexity, and usually we will denote it as n square. N square. So here the number of steps required is more than the input size. So if the input size is n, the steps required to execute the problem will be n square. So double the steps, double the input size. Okay, so that's why we will represent it as an order of n square. So steps required to execute the problem is double the input size. Double the input size. So if n is an input size, then n square will be the steps required. And this algorithm is very slow if the size of input is more, because it takes a double of the steps, right? So this type of algorithm will be slow for large inputs. So if the input is large, the number of steps required will also be large. Right? The best example for this type of complexities we call it's a bubble sort. So the main logic of implementing the bubble sort is comparing the consecutive elements. So after first pass, the highest element will be residing at the last position. So in the first pass, we are going to compare consecutive elements. Okay, so in an array, if you want to compare the consecutive elements, first element and second element and third element and fourth element, so like that, if you want to compare the consecutive elements, then this complexity will be suited. and that will be the example for this particular complexity, quadratic time complexity. Right? So hope you understood this one, and apart from this we are having a cubical time complexity which is represented as n cube, and more time complexities are there. So these are the mostly we will see these type of complexities in different algorithms. And one thing I'm just repeating, so the time complexity may vary according to the input size. So the time complexity will be not same for all the input sizes. So if you change the input size, the time complexity will also be changed. So that's why this time complexity, there are different types time complexities. Right? So let's stop here. Hope you understood this one, and if you are having any doubts regarding this types of time complexities, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.